So all set here, and we need to copy the whole chunk again. All right, we commit it already, and then we will update it yet again. All right, so we know that this time round the code XENTR has been created. So what we want to do is to basically update set account code to this, name to entertainment. Okay, FR type to PL, not PLOS, right? And subtype to this, where account code is X entertainment. Okay, and then insert. Right, because that's another command. It'll be clearer if we just basically do this. So update this one. Remember the semicolon here, very important because we are having two commands, two SQL commands. Okay, so here, then we can also do the same thing, and then back here. Okay, insert into account code entertainment, right? Right, and also PL, not PLOS, expense. Good. So we have two lines here. Now what we can do is that because we have committed it, we can also have an input to see. Press enter to continue. Okay, we'll comment this out first, just to let the whole thing pull through. And before we start, we should look at our account table. First thing first is we really want to delete this row. Okay, gone. And we want to make sure that these are all set to PL. So that's quite easy, almost like editing in Excel. Okay, obviously if there are 100 rows, I wouldn't be typing. I would just programmatically do that. Okay, good. So we are back to here. I think we are set. So let's run it. Okay, and we would expect the final account table to be we need to commit it just as well, right? So we'll expect the final account table to have row 11 and spelled correct. So let's do it. Okay, number of rows change, everything done. All right, good. First one, oh, this one was an additional thing, right? We shouldn't have it there. But the commit did occur, and let's see if we successfully get the correct spelling, entertainment, and PL, not P loss, not P loss. Okay, so what happened? We can certainly select this, delete, and commit it back to the database. And over here, let's just pause for a while. So after performing the first update insert, we commit, then we pause. Don't do the correction yet. Have a look at SQL, and then we run the second part. Okay, so let's do that. So we run the first part, is hanging there. We quickly move over to SQLite Studio, perform and refresh. We do have the 11th row, but it's spelled wrongly with the enter, right? So it's correctly done. We know it's there, and it's spelled wrongly, P loss. And then when we press enter, it will continue to perform an update based on the same primary key XENTR. So let's do that. And this time around, we run over to SQLite Studio, refresh, and it's being corrected without having a new row being entered, nor error occurring in our Python program. So this will be the safe way, right, of not violating SQL rules and still be able to perform insert or update kind of intention. Let's go back to our slide here. We can, of course, run using the new version of SQL if it supports the on conflict in the insert command. So if the documentation says you can use on conflict, this is a preferred way because there's only one statement. So one statement does it all, and we are able to basically reduce the back and forth from Python to SQLite and then to the database by half, right? The traffic. So let's come back to our Spider, create a new file, basically inherit everything from the previous version of update insert. And this time round, what we need is just insert into. Insert into account the values, right, of enter, right, entered, just to distinguish it from the previous example, prof loss, yeah, and expense, and then close bracket. And we expect this is like a normal insert, but the new kid on the block, the new change is on conflict in the account code, because this is the primary key and it cannot clash, right? Do update set, do this command called update and set what? Set the name to entered, uh, essentially the same data that we would have wanted to insert, right? Because there's a clash, so we update and write over the existing data. Don't care what they have, just override it with entered and fr type equal to prof loss, yeah, and just to use the nice extension here, excluded dot subtype. Whatever it is, just keep it there. And that is the end of our string. Okay, good. So then we execute and commit. Yeah. Okay, then we also update the new copied version, and it will basically have the same command, everything, except this time round, entertainment is spelled correctly. The data is inserted correctly. We updated the data, and likewise here, yeah, and yeah. So everything is the same. Okay, then what happens? Okay, so let's go back to our SQLite. First of all, we manually just delete it, commit to the database. So now our Python script will look at the database like this because we have committed it. And we will just run it. Because I have the enter here. That's nice because we copied over, right? I wasn't expecting this, but it's nice. Then since it's there, we can update in SQLite. We see that the first part was done successfully without any error, and entered was inserted as a new row 11 together with the sort of incorrectly entered code, FR type, prof loss. So the next segment is pretending to be another login, another session, another review browsing, and say, oh wait, the prof loss is to be corrected to PL, something like that. So we're just pressing enter to let it continue to run the code and read back again with the refresh, and we see that it's been updated with entertainment and PL correctly. So fortunately, my version of SQLite supports on conflict. So if yours works, then congratulations. So use this version. It's a one SQL command version, certainly a lot more lightweight than the previous two statement version. Furthermore, because it's one command, it can be run using execute instead of execute script. And well, no big deal, but it's just nicer. All right. And let's come back to our classroom slides here. Next thing we want to learn is how to delete from the existing table. So very simple, we have learned this SQL command before. All we need is to implement the 3-color block, yellow, green, white. So by now you will do it yourself, the yellow and the white. And the green one is basically the standard stuff. SQL command will change to the SQL command. That's all, right? Because it's always execute, then commit. So let's try to delete from the database that we corrected just now, all the subtypes having asset, delete them, ending up with only 8 rows together with the entertainment row. Okay, so let's do that in our Spider. Create a new script. Copy everything from 7 And let's do a quick scan, connect to the database equals, okay, so what we want to do is to delete from, okay, so delete from account where subtype is asset. So I want to, discard all the rows. I don't know where, how they spread out or whatever. So long as the subtype is asset, delete them. Then I execute the script and commit. Now, obviously, we normally would also like to check select changes to see how many rows were actually being deleted. Huh? But I'll leave that to you. So for now, we'll just do that. So going back to our SQLite, we have the entertainment, everything. Refresh again just to make sure. Okay, now we run our delete script and see. Okay, no error so far. Coming back to our SQLite Studio, we do a refresh, and nicely, all the subtypes with assets, all the rows are all gone, all deleted. Nicely, all right? So this concludes our demonstration of how to use programmatic access from Python to perform all the row operations, plus a very, very powerful insert on conflict or update and insert operation. See you in the next video.